In this video, we're going to go through two examples of mathematical modeling. Let's go ahead and start with the first problem. In addition to an annual salary of $72,000, a teacher in Garden Grove also earns $43 an hour for additional duties. Write this teacher's monthly earnings as a function of hours worked on additional duties. Now, we're going to write monthly earnings as a function of hours worked. I want to talk about the notation here. If I have this, suppose I have this function, f of x equals 2x plus 1. We would read this as f of x. Or I could read this as a function of x. In other words, whatever I get for this value is going to depend on my input for the x. This is a function of this independent variable x. With regards to what we're doing in this problem, I need to write my monthly earnings, which I'm going to call m. I need to write m as a function of hours worked, which I'm going to call h. So what I really want to end up with here is m equals something that has an h in it. So let's think of how this person earns money. This person has their annual salary of $72,000. Now if I take the $72,000 and divide that evenly among 12 months, I end up with $6,000. So it's the annual salary plus the hourly wage. The hourly wage is $40 per hour. So what I end up with here, the monthly earnings is $6,000 for the salary plus $43 per hour. Now that I have this function written, we could use this to determine how much the person will bring home per month based on the number of extra hours they've worked. Go ahead and look at another one. The height h of a tin can in the shape of a cylinder is equal to its diameter. So I'm going to write down what I know here. The height h is the same as its diameter. The diameter here goes across. I could use h and d interchangeably. So now we have h and d. We could use those interchangeably depending on what our purpose is here. So we're going to look at a first. Express the volume of the tin can as a function of h. We're working on this piece. All right. Well, volume of a cylinder. Volume of a cylinder is going to be the area of the base times the height. Now if I look at the area of this base, I'm really looking at the area of a circle. And area of a circle is going to be pi r squared. But the thing here, though, is that I want to write this as a function of h, meaning when I write my formula for volume, it needs to be v equals a bunch of stuff that has h's in it. No other variables can be used. So, area of the base is pi r squared. And I'm just going to write this first without substituting, times the height, which is h. And the radius, I could say d divided by 2, or because I need to use h's here, maybe instead of d, I could write this as h over 2 for my radius. So, I have volume equals pi times the radius squared times the height. And for the radius, we're going to say h over 2. When I simplify this, I have v equals pi times h squared over 4 times h, which is pi times h cubed. I wrote that a little sloppy. Let me clean that up here. H cubed over 4. And this is the volume of the tin can as a function of h. It's a function of h because I have h as my input. Let's go ahead and look at B now. For B, it says express the surface area S of the tin can as a function of D. Well, if I'm going to express the area of the tin can, let me delete this stuff here so we can start fresh. If I'm going to express the area of the tin can as a function of D, what I need to do is make sure that I'm only using D's in my formula. So, clear all this stuff out. Now we are looking at this. The surface area of S as a function of D. So this should be S equals a bunch of stuff with D's in it. Well, let's talk about how you find surface area. I'd like you to imagine that a tin can. A tin can has a couple components here. We have the top of the can. We have the bottom of the can. I'm going to color those both in yellow. And then we have the label of the can that goes around the outside. Now if I look at this and I break this up into 3 separate pieces, we have the label piece plus 2 circle pieces. Well, the area of the label, it's going to be the height of the can, h, times the base of this rectangle here, which is actually going to be our circumference. And the formula for that is C equals 2 pi r plus 2 times the area of the top of the can and the bottom of the can. The area of the circle is pi r squared. The only thing though is since I'm writing this as a function of D, I can't have any D's in my formula. But I know that H and D are equal. So what I'm going to do is I'm going to go ahead and make these changes. And everywhere I have an H, I'm going to replace it with a D. Because I know H and D are equivalent. So, surface area is SA equals, we're going to do the area of this rectangle. Area of a rectangle is base times height. This is going to be 2 pi. For the radius, that's going to be half of my diameter, or D over 2, right? Because radius is half a diameter. So this is my base times my height, which is also D because the height and the diameter are equivalent, plus, now we're going to do the 2 circles. That's going to be 2 times, I'm going to go square here, pi times the radius, which is D over 2 squared. So at this point, we really just need to clean all this stuff up. I'm going to slide this up a little bit here. We have surface area equals, this is going to be, my 2's cancel. So my 2's cancel. I have pi times D squared plus, this is going to be 2 times pi D squared over 4. My 2 and my 4 reduce. This becomes a 2. That becomes a 1. So I have surface area equals, this is pi d squared plus pi d squared over 2. I recognize that I need a common denominator. So I'm going to go ahead and do that. Now I have 2 pi d squared plus pi d squared. That's going to be 3 pi d squared over 2. So I have now written my surface area as a function of d. And there we go. I do want to point out one thing. Pi is a constant, pi is not a variable. All of this is based on the input. My surface area is a function of this input value for d. And that's going to wrap this video up. Thank you so much.